Okay, what we're going to do is we're going to look at a type of stoichiometric question where I take two solutions. So I'm going to take a barium nitrate solution and combine it with a second solution, a solution of sodium sulfate, and we look at our products. And so one of the things we're going to ask is, what's my theoretical yield? How much barium sulfate do I expect to get? And then if I get an actual yield of the salt, what's my percent yield? Both of those are questions you should be able to do already. But then the added question is, what is the concentration of each of the insoluble ions, or each of the ions that make up my insoluble salt after the reaction is done? So we'll talk about how we can determine that as well. Okay, now we know that whenever we start off with these questions, the first thing we start off with is our balanced equation, and then we write out our givens. So we know that we have 35 milliliters of that. Remember, when we do our calculations, we have to convert this to liters. We have 25 milliliters of this. We have our actual yield. We get our molar mass from our periodic table, and we were given our concentrations. So now, remember, we're given the amounts of both reactants, so we're in limiting conditions. So you can determine your theoretical yield using either technique, but the first thing you have to do is establish limiting. So now I'm going to insert a pause in the video, and I want you to pause the video and calculate your theoretical yield. Remember that you have to determine which one's limiting. Okay, so for simplicity's sake, what I'm going to do is I'm going to determine the mass of the product that each of these produce. And so I'm going to determine the mass produced from my 35 milliliters of my 0.1 barium sulfate. And we know that we have to convert this volume to moles. And to go from volume to moles, I multiply by concentration. And then to go from moles of this to moles of that, I need my mole ratio. And then to go from my moles of my barium sulfate to my theoretical yield, I need my molar mass. So I can substitute in my values, and I get that my barium nitrate will produce 0.817 grams of barium sulfate. So now I'll calculate how many grams my sodium sulfate will produce. Again, I'm going to have to take the volume, and I can multiply by the concentration. That will get me to moles. Multiply by a mole ratio, give me moles of my barium sulfate, and then multiply that by the molar mass. So we substitute in our values, and we multiply, and we get that my 25 milliliters of my sodium sulfate will produce 0.875 grams of barium sulfate. So now we can look at it and compare, right? So my theoretical yield of barium sulfate from the first reactant is 0.187. The amount produced from my second reactant is 0.875. Now, since this value is smaller than that, that tells me that my barium nitrate solution would produce less product. Therefore, my barium nitrate is my limiting reagent, and this would be my theoretical yield of my product. Okay, and so now that we know our theoretical yield of our product, we can easily calculate our percent yield, because we know percent yield is actual yield over theoretical yield. And we were told our actual yield. We now have our theoretical yield from our limiting reagent. So I'm going to introduce another pause for you to calculate your percent yield. Okay, so we substitute in our values, and we get our percent yield. So those two are not that, or neither of those two are that difficult. The question that's more challenging is, what's the concentration of our sulfate ion and our barium ions? Okay, and so let's take a look at this. Now, when we're looking at this question, it's actually easier to think of it in terms of our net ionic equation, because we're interested in the concentrations of the ions that make up the solid that would form as a precipitate. So we'll write it as my total ionic, and then I get my net ionic equation. So barium ions plus sulfate ions gives me barium sulfate. I don't care at this point, because we want to know the concentrations of each of these after the reaction, I don't care about the nitrate or sodium ion concentrations because they're spectators. So let's take a visual look at this. So I have a solution with barium ions in it. Obviously there's a nitrate as well, but spectator, we don't care. And I have a solution of sulfate ions. And yes, sodium's in there. Again, spectator, we don't care. And I'm going to take them and pour them into one container. And once I do, they're going to mix together, and now they're going to be all together in the same total volume. And so as a result, they're now all together in the same amount of solvent, or the same amount of water. And the amount of water that they're both now in is the amount of water that came from here and there. So I had 35 milliliters there and 25 milliliters there. So now I have 60 milliliters. So now these two ions are in 60 milliliters of water because it was combined, and they're going to start to interact with each other. And whenever they interact, they're going to precipitate it out. Sorry, I skipped a bit to that. I got excited. Okay, now, before we look at their interaction, a couple of things. We know that my barium nitrate solution was limiting, so as a result, this ion is going to be the limiting ion. Because it came from my limiting reagent, it's going to run out first. And we know that my sodium sulfate solution was excess, so this ion is excess, and it's not going to run out. So when I look at my combinations, as they bump into each other, they're going to form a precipitate down at the bottom. My barium ions and sulfate ions are going to be removed from solutions, but all of the barium ions are going to be removed, and at the end, I'm left with sulfate ions. All of my barium ions, because it was from the limiting reagent, and therefore is the limiting ion, are consumed. And I'm left with sulfate ions. Okay? So since my barium ions are limiting, its concentration is easy to calculate because there should be none left after the reaction, so its concentration will be 0. It's all consumed. The more challenging one to determine is my sulfate ions. And so this is the one case where I want to work at the mole level. And so what I'm going to do is I'm going to calculate how many moles of sulfate I have in total. I'm going to calculate how many moles of sulfate are required to react with all of the barium. And then the difference is my excess moles of sulfate. And then I can then turn that into a remaining concentration of sulfate. Okay, so I know that my moles of sulfate remaining is my moles that I have minus my moles required. So let's calculate our required first. And to get our required, we have to calculate our moles that are required to react with this. Now, remember, this came from my barium nitrate. So therefore, my moles of barium nitrate, I'll calculate that first, is equal to the volume of the solution times the concentration times the mole ratio. For every one of these, how many barium ions do I get? And that's my mole ratio. So I had a 35 milliliters of a 0.1 mole per liter barium nitrate solution, and for every one barium nitrate that dissociates, I get 1 barium ion, and that's where my mole ratio comes from. And so I get my concentration. Okay, now that I know my moles of barium ion, I can now use that to determine my moles of sulfate that I require, because it'll be equal to the moles of this times the mole ratio. I'm already at the mole level, so all I have to do is multiply by a mole ratio. So my moles times my mole ratio, and that tells me that I require this many moles of sulfate. Okay, so now let's calculate how many moles of sulfate that I have. And remember, my sulfate came from my sodium sulfate, so my moles of sulfate is equal to the volume of the sodium sulfate solution times its concentration. It gives me my moles of sodium sulfate times my mole ratio. Okay, and so now I take that, and I get that I have this many moles of sulfate. So now I know how many I have, I know how many I required. I can calculate my remaining because it's just the difference between the two. I have this many moles remaining. So I'm almost done. I just have to now convert that into concentration, and we know that concentration is moles over volume. So I just have to take this moles and divide it by the volume in which that many moles of sulfate are occupied. And remember, we talked about how when I combine the two solutions, their volumes combined. So therefore, my total volume is 60 milliliters, not the original 25. And so I get my concentration.